Okay, guys, we got a really short one here, and it's actually a calculator section. So if you don't have your calculator on yet, pause it right quick and run and get your calculator. Okay, just like when we did some of the exponential applications, we needed a calculator, right? Those exponential growth and decay and interest formula. And again, because logarithms are exponents, sometimes to get an actual numerical answer, sorry, we also need a calculator. Okay, so on your homework, on some of the problems, you're going to need a calculator. On the test, there will be no calculators, right? We'll just leave our answer. Instead of getting a numeral, we'll leave our answer as something like natural log of x. Okay? Okay, so here's what we were also mentioning last time. If you don't have a base written, it's understood to be a base 10, right? Our numeral system is a base 10, so that corresponds to that. There's also another notation. Remember the E from our exponential? Actually, it's called E because it's the exponential, so of course logarithms are exponents, so we're still going to run into E's a lot. And so because it's so important, it gets a special designation. If you see this LN, right, then that's read natural logarithm. Please don't call it ln. If you have to, you can say LN, right, LN of x, but don't say ln of x. That doesn't make any sense. And so here is where we could just say log of x. If you just say log and then a number, that means, oh, log with base 10. And then this is lnx, or natural log of x. Okay. So use a calculator to find these values. So just grab your calculator, you should already know where the LN button is because we used it last time to find the E. And right beside it, more than likely, is going to be your log button. So just, you hit the log and you hit 1,000, close that parenthesis, okay, and I got 3. Okay, same thing, log of 42. Let's round to the nearest hundred, so 1.62. If you're not getting these values, let me know and we'll figure out what's up with your calculator. Or if you can't find these, negative 2.23 rounded to the nearest hundred. Okay. So these values we would not have been able to get without a calculator. They used to have giant charts that you used before calculators, if you're wondering. But this, look, a 3. That's because, and this is what we want to get used to, I'm going to go ahead and preview us for next time. I can rewrite this as 10 cubed. And remember, anytime these bases are the same, it just equals that exponent. Interesting, right? Okay. So same thing for natural log, right? Plug in natural log of E cubed and get 3. Notice because these bases are the same. If it says natural log, it's a base E. Natural log of 142, you should get 4.96, 4.955, dot, dot, dot. Natural log of 0.005832, negative 5.14. Rounded to the nearest hundred, right? Okay, so there's that. But really what we need out of this section, in addition to being able to use our calculator period on logarithms and natural logarithms, is this change of base formula, right? The only values in my calculator, the only bases that I can take in my calculator is base 10 and base E. And we've already seen from that last section, oh, we can have all kinds of bases, base 3, base 2, base 5, base 1/2, right? So I want to be able to change my base, and here's my formula in order to do that. It's a pretty easy formula to remember. We can change it to any base we want, right? I could change this to a base 4,000. Wouldn't help me because I still couldn't solve it. So I'm either going to change it to a base 10 or a base E. Personally, I always change it to a base E, literally, because that's how lazy I am. I can write LN instead of LOG, right? But it doesn't matter, whatever you feel most comfortable with. So I'm going to change this to any base I want, and notice the position here. The X, the argument, is above the base, and so that tells me, oh, same way in my formula. The argument is what goes on top. The base is what goes on bottom. All right, so to practice that, I want to change this. Again, you can change it to log with base 10 or natural log. I'm going to change it to natural log, also because then you can cursive natural log, and it's just like writing one letter instead of 3. Whatever. Okay, the 17, notice, is higher than the 5, so it goes on top. And we can get, then we do natural log of 17. Don't forget your parenthesis to close that, divided by natural log of 5. And we get an actual numerical value. Just one time, just for kicks, let's change it to base 10. Let's plug in log of 17 divided by log of 5. And voila, we better get the exact same number. Change it to any base you want. In particular, one of these two, right? Okay, so over here, the 0.1 is above the 2, so I'm going to keep it that way. And then I can just plug it in my calculator. Natural log of 0.1 divided by natural log of 2. Negative 3.32. Okay, our change of base formula. Now, I'll need that on my homework, but don't forget, whenever we're on a test, we'll just leave our answer like this, right? So I won't need my calculator. But for homework, I'm going to need that calculator. Okay, see you next time.